Good afternoon and welcome back. So this session is on modern electrical distribution equipment, and we have a very good panel of manufacturers from international companies who will talk about not just products but also solutions in the area of distribution. And also we have a young man who is from a very young company which will also doing very well, and they will also showcase the work that they are doing. So one after the other, I invite on the stage Mr. Ernst Kam, Senior Manager Consulting and Analytical Service, SNC Electric, Melbourne. He's based in Melbourne, Australia. Although the company is from US, he has over 30 years of power industry experience. And his experience is in protective device application, analysis, improvement, etc. A lot of good stuff he has been doing. So he is also a senior member of the IEEE PES and past chair of PES wind and solar plant. Welcome, Ernst. Next on the dais is Mr. Simarpreet Singh. Simarpreet is the executive director at Hartech Group. He is one of the this company is one of the largest and fastest growing engineering, construction and manufacturing companies in the power and renewable. Simarpreet leads the group strategy and heads the renewable and manufacturing business of the group. He is an electrical engineer and an MBA from SP Jain, Mumbai. He was named in the SQ list of top 40 under 40 entrepreneurs and also appointed as the youngest chairman of PhD Chambers of Commerce. Welcome, Simar. Next in the panel is Mr. Sangram Patil. Sangram Patil, he has contributed in various aspects of power system analysis, which includes T&D, planning, steady state analysis, dynamic performance, industrial networks, protection coordination, etc. He has knowledge of various tools like PSS Syncal and has used them. He's an expert in various aspects of power system analysis and modeling and simulation from Siemens. Next, I am pleased to invite Mr. Ashish Trivedi. Mr. Ashish Trivedi is Associate Sales Director and Head of Building Segments in ABB, India Limited. He has over 3 decades of experience. Welcome, Mr. Ashish Trivedi. And also we have Mr. Preetham. Mr. Preetham Mangare, he is from Schneider Electric, and he also from the Mumbai office, taking care of the power sector distribution. Yeah, welcome, Mr. Preetham. So in the order, this will not be a panel discussion. The various colleagues here, they would like to come on the dais and make some presentations. So first I would like to invite Ernst. Ernst, come over to you.
Good afternoon. It's my privilege to be here with you this afternoon, and thank you to Vikram and the conference organizers for the opportunity to speak here, as well as being part of a distinguished panel. I appreciate the opportunity. I'll be talking about innovation for the modern distribution system, sharing with you some of the innovative solutions that SNC Electric Company has introduced for distribution systems in the last decade. As I start thinking about the presentation today, the thing that came through very strongly yesterday during the panel session on regulations and policy was that everybody agreed that this was the time for transformation, and that a lot of the things that have been talked about for a while are expected to happen soon. So this is literally a new dawn for the electric power industry in India, and we would like to share with you some of the contributions that we've made here already, as well as in other parts of the world. So I'll start off by just discussing with you different distribution lateral protection practices that include single-phase laterals that are typically protected with fuses, and then also the schemes that are applied to protect the distribution feeders. So there's normally two systems that are involved, fuse blowing as well as fuse saving. And fuse blowing, as the name suggests, is basically a scheme where the substation protective device is set such that in response to a fault on the lateral, the fuse would operate first before the substation protective device would operate. For both a permanent as well as a temporary fault, the result is the same. Once the fuse is operated, that portion of the lateral is now disconnected from the feeder, and the crew is required to go out to repair the fault, or find and repair the fault, and then replace the fuse to restore service to the customers involved. The fuse saving scheme in the situation of a temporary fault is actually such that the substation protective device will be operating first in the event of an occurrence on a fault on a spur or lateral, and then reclose. If it's a temporary fault, it'll immediately restore power back to all the consumers on the feeder. But of course, everybody sees a temporary interruption during the time that the substation device opens. So SNC introduced what we call the TripSaver 2 cutout mounted recloser that is basically our innovative and cost-effective solution to lateral protection, which combines the benefits of fuse saving with the benefits of fuse blowing. So the device itself is self-powered, and it basically gets its power from the line. As long as there's a minimum of 3 amperes flowing, the device will operate as expected, and it will protect the lateral through a vacuum interrupter that may be configured to operate 3 to 4 times, reclosing into a circuit to test if it's a temporary fault. It's also developed such that it fits into SNC type access fuse cutout mounting or a McLean cutout mounting. And then it also will go through its operating sequence and will drop out in the event of a permanent fault, so that there's a visible indication that the device is operated and that there's a permanent fault downstream from the device. There's also a mode selector switch, which is important for safety purposes when the crew is working downstream from the device, that will enable the crew to flip over this mode selector switch from the ground using a hook stick, and then also making sure that the recloser won't reclose during the time that they are working on the line trying to find the fault and repairing the fault. So basically, for the TripSaver, the business case is around the fact that there's a significant reduction in customer minutes of interruption, that you also essentially eliminate the effects of the long duration outages and basically improve the reliability for the customers, helping them to save money, and also for the DISCOM to save money as well. The same applies for the most part also with the fuse saving scheme, some of the same benefits that you see there as well. And we're actually currently busy with a trial in India where you can see these units installed on a small spur fairly close to the substation in this case. For the main feeder protection, the general approach is to use a circuit breaker for the protection, or a RMU with the associated fault interrupting capability. And SNC introduced what we call the Intelect pulse closer fault interrupter. That's basically a feeder protection solution that avoids the negative impacts of reclosing through pulse closing, which is basically a point-on-wave technique for timing the closing very accurately and introducing a very small pulse rather than cycles of fault current that a recloser would typically introduce. Everything that you see on the slide there is integral for the unit. It has very accurate current and voltage sensing. It also uses a magnetic actuator to open and close each pole individually very quickly, which is what allows us to produce a pulse rather than a fault current. These units are available in the overhead style as well as pad-mounted style for underground networks, such as here in Mumbai. And then there's also a substation version that we call a compact style Intelleruptor. And these units also have an integrated communications and control unit, so everything could be integrated without the need for any external power to power the unit or for external sources of supply for communications and so on. This is an illustration of what you would see with a permanent fault occurring when you're using a recloser. The initial fault will cause the device to trip, and in this case, it's configured to reclose twice. So you see that the same effects occur on the system, that the fault current is basically multiplied to occur 3 times, which ends up putting more stress on equipment and can cause damage to equipment. Opposed to that is the pulse closing technology. For a permanent fault, you won't be able to do anything about the initial fault current, but then after it is stripped open, it'll test the line to see if the fault is still there or if the fault has disappeared. And it'll actually do it in both positive and negative polarities to make sure that the current that it's seeing is not magnetizing, transformer magnetizing inrush current, and it will repeat it as many times as it is programmed to attempt to reclose. So in this instance, with it being a permanent fault, it's not actually going to reclose, it's going to remain open, and the crew will then go out to find and repair the fault. In the case of a temporary fault, once it's determined that the fault is no longer there, then it will be able to close and restore power to the users on the feeder very quickly. This is a comparison of an actual laboratory test that looked at the energy that's being consumed during a reclosing event compared to a pulse closing event. And as you can see from the illustration there, it's quite a significant difference. In the general case, the Intelleruptor would produce less than 5% of the energy that a recloser would produce for the same situation. The business case for the Intelleruptor basically revolves around the fact that the pulse closing technology eliminates damage to equipment, splices in conductors that might be severed during a reclosing event. There will not be such stress on the equipment with an Intelleruptor. Then there's also the high accuracy sensing that allows multiple devices to be coordinated in series, so you can have 5 devices in series and still properly coordinate, compared to if you had a recloser, you won't be able to do so. Then there's also additional technology associated with the pulse closing capability that allows us to test for a fault, and if it's required, we can trip all the devices in series if they're not able to coordinate, and then we test as each device is opened. We test after the voltage comes back, we test, and if there's no fault, then we close the device. So in this instance, with the fault shown where it is between the 4th and 5th Intelleruptor, you would be able to close everything up to Intelleruptor number 3 to restore service, and of course Intelleruptor number 4 will remain open. So this is an actual trial installation, also here in India, a 33 kV Intelleruptor that has been in service for close to 9 months now, and has generally yielded very positive results for the customer involved. The final item that I wanted to make you aware of is our IntelliTeam SG fault location isolation and service restoration system that basically uses distributed intelligence to restore power to users very quickly by reconfiguring the circuit and opening switches to isolate the fault, and then closing switches to connect the unfaulted parts of the system back to a source of power supply, so you can restore service to most of the customers in orders of tens of seconds generally. So I appreciate your attention, and I thought I'll leave you with these words of wisdom and wish you the best for the rest of the conference. Thank you.
Excellent, Ernst. Thank you. Very good time management. I must compliment you. Next, we will invite Mr. Preetham. Mr. Preetham from Schneider. Yeah. Can you make your presentation, please?
Good afternoon to all. And today I'm going to talk about the modern digital equipments. So basically what we see as a trend, what has happened with the equipments over the period, and how do we see it changing. I come from a medium voltage background, so more into medium voltage, different exposure I have had with different type of switch gears. That's how I have been coming from these years specifically. So moving ahead, what I would like to first highlight is there are two type of change what we see in the medium voltage or as such electrical equipments. First is on the hardware side. That is what we see changing. So if I demonstrate here the different types of switchgears what we have seen in the past, different technologies. And then we see that now things have changed with the change in the technology, not only on the hardware, that is on the equipments, but they are becoming smarter in a way and more connected. So today we have a limited change on this particular portion. I would say this would contribute to only 20% of the change, but more will come with the digitization and connected to the cloud, basically which will change the entire scenario. Today we have certain technologies which are already, you see the best of whatever was available in the past, a combination which is more compact, which is more safe and reliable in a way, but it is reaching a limit to a certain extent, and the time period is longer here. But the change which digital aspect is going to make is going to be very, very fast. So in terms of electrical equipments, what we often see is on the air insulated and gas insulated technology. So it is already combined, and we see a new technology trend of solid insulation in this way, which is giving the benefits of both the technologies today. It's equally safe, I mean, in a way, but more compact and able to answer to the queries from the industries, the questions, the solutions which the industry is seeking for. Next technology trend which I see is in the transformers, of course, with the Vegeta oil, of course, there is an aspect of making the transformers more compact and able to function at a higher point, which if you imagine so many transformers available today in the distribution area, if the trend changes totally, which makes things more compact and as well as safer to be able to run at a higher efficiency, I think this will change the entire scenario. at the distribution level. Next is, of course, this is a combination of various switch gears, various components which we have in electrical systems put together. We call it a containerized substation or a E-house sort of thing. But this is what is going to be the next answer as well, because of the technology change, what we have seen, which goes inside this. And this is what will be able to cater to the larger dream of being able to reach out to the areas where today we are not probably able to do it. So we have an experience, hands-on experience on these kind of solutions where we had a lot of challenges on the space, specifically in the metros. Next is, the site topics. But I think with this new solution and the change in the switchgear technology, this is going to be very, very efficient. So these are the substations which we couldn't have imagined to fit in such a compact size and such a sized locations where earlier it was not feasible at all. So this is something to summarize on the hardware side, what I see. But of course, as I said, this is only 20%. More is on the digitized version, which are making these equipments very, very smart, connectable, and of course, they are giving us answers to our queries from the past. So of course, we have seen digital evolution. What we see here, it's all everywhere. And it's coming more faster with the millennials. They are born with it. We see them in every other field, areas where this is applied already. But I expect this to move more faster in the electrical arena. And this is where I think it will bring a bigger change. Today we have been very, very preventive approach in the maintenance areas of this equipment, which is to a large extent very, very limited. And I think this will move, or rather have already moved to the next level of predictive maintenance, where we see that we no longer have to wait for a time to go and maintain our equipments in the year. This is somewhere which will become more smarter to handle more number of equipments from a centrally accessed area. As well, it will bring all the kind of shutdowns which are unplanned and improve our cost efficiencies to a large extent. This is something which is going to be a win-win for the manufacturers and the users, of course, but this is the solution for the queries which have been raised in the past. And now I see that it is moving at a large speed. And this complete change is going to make the electrical aspect, equipments much smarter than what we have today. There are, of course, some small, topics where we need both to work together to see how this can be moved fast, because the experience from the site is what is being taken into consideration before, building up such ideas and turning them to a reality. Today we have some solutions available in the industry, and this is at large going to help a lot on the preventive aspects, where remote access, even to the extent of predicting the next steps for the users, is what going to be of a great help for the industry to grow faster. Yeah. So I think with this, I would just summarize that this is an area where together with along with the industry, we need to really work on certain aspects, making things available, implementing them, especially in the digital area, and this is going to grow multifold than what it has in the past. So with this, I would close my introduction on this topic, and thank you all for listening.
Thank you, Preetham. So, as he said, intelligence in conventional equipment like switchgear is very important now, and we will see the important role it is going to play. The more granular is the control, the better it is for the consumer and also the utility to manage the network. So next speaker I'll invite is Mr. Sangram Patil. Mr. Sangram, you'll talk on his experiences with the system study of distribution network. So you have 10 minutes, Sangram.
So good afternoon, everyone. So today we are living in the largest energy transformation. So where everyone is thinking about how to improve on efficiency and reliability point of view. So in today's scenario, the reliability and power quality, these are the two important aspects which energy supplier are more thinking about. Because of the power quality concerns and the disturbance, so industry is also now focusing on the power quality. So I'm just covering today this aspect of power quality. So what is happening if power quality is not correct, or if there is not just a minute. Yeah. Okay. So if you see these slides, you can understand the issues which is resulting because of the power quality. So on the first slide on the top side, you can see the failure of capacitor, which in turn again creating the impact on controller, and also you are losing the important equipment or the particular feeder. In the next picture, you can see it is a similar phenomena. Also, it is because of the power quality, wherein the controllers are failed. So we have seen these phenomena over several years of experience in analyzing different disturbances. So these are the pictures, if you can see on the right side, so which gives the information on the power quality data. And the third picture is also, I will explain in the next slides on the details of it. So in a distribution environment, power quality is important, and the voltage is also the important criteria you have seen in the national and international standards. They have already specified the limits for this. So to understand this power quality, if you can see, there are various factors. Start from the harmonic, start from the flicker, voltages, voltage sags, voltage swell, and there are so many. So this is need to be monitored. So why it is required? Because from the different disturbance data or disturbance record information, you are only having the limited information to that particular event. But over the year of experience, what we learn, the various power quality parameters having a trend or the information that before any tripping or before any outages, it gives certain indications. So one has to monitor this power quality parameters to act before, or I will say this is a proactive approach before a major damage happen or there severe outages come into picture. So how we are doing this? Because we are coming across with various disturbance cases. So this is one particular structure we have using when we are doing this. So at the bottom side, you can see we are using the monitoring devices. So monitoring devices, it should be capable enough to capture high frequency ranges. So at the bottom line, you can see the image or the booth. So you can put, you can collect this data from the different locations or different feeders. So after collecting this data need to be transferred, because these equipments are having collecting a large amount of data, and this need to be transferred. So you require a reliable communication for this. So either you can use the internal communication network of the plant, or you can, again there is a IT security issues also there. So to avoid that, you can use the wireless communications also. So both way it is possible. So we have shown in this slide that how the various ways of transferring the data. Once the data is transferred, then the important aspect is this need to be, because this equipment collects so many data or captures so many data. So this data will come into the huge amount, and that amount of data need to be understood or need to be interpreted by the operator or by the expert. So you have heard about the data analytics, so which is a key for a future, because this is not, in power quality analytics, this is not the simple data science, because it requires a person who is having a background on evaluation of different disturbance record. It should be a power quality engineer who understands these different events, and no doubt on a different network scenarios. It's not only the distribution grid. He has to have understanding on the distribution network, industrial network, and various processes. So with the experience we are having at Siemens, we have developed this structure for the power quality analytics. So you can see the raw data is coming on the, and then the data, we are using the machine learning method or artificial intelligence to differentiate between the abnormal and normal states plus the operation states. Because it's not only, if you can see the picture where large bubbles are there, which are the normal state of the system, and there are certain dots onto the right side which shows you the abnormal states. So now you differentiate it between the abnormal and normal state, but you have to understand the operation state of the system, because that is also important, because power quality parameters varies based on the different operating states at light load and the heavy load conditions. So one can go by the, we are using here the machine learning, and another is the artificial intelligence, because there is another the waveforms which we can capture through this is it has a trend, or it is a time envelopes are there. So you can capture this event through the machine learning or the artificial intelligence. So the outcome of this is you have to convert these parameters into facts, because that is the important to understand the state of the system. So once you know the facts of the system, then these facts we are putting into the diagnostics, where we have created the rules. So these rules are based on the experience which we are having. So this diagnostic tool or the tool which we have developed is acting as a knowledge, plus it is taking as an experience into account, and it is giving a different states of the system. So you can see on the bottom side there is a different state we have mentioned. So therein you will understand whether these are the critical states of the system or not, because there are these systems, these states might be because of the operational or because of the fault conditions. So after evaluation of this data, what we understand, every outages or every disturbance stores the data. So we need the historical data to be available. So what, if you can see this slide on the upper side, there is a timeline. So you need a continuous monitoring of the data in your system or a different feeder. So this top curve is showing the different colors and also the dots. The dots are the outliers of the system states, so which need to be understood or which need to be evaluated further to to confirm whether these are the critical or not critical for your system. So if you see on the bottom side, we have mentioned there are 5 states we have mentioned here, or 5 scenarios with respect to time. So out of this, the 5 are showing the states are different, but these are the normal state because of this starting of certain transformers or devices or switching of control or disconnection of a control. But at the last, you can see there are so many outliers are there. So with these outliers, when we evaluated this, then we understand this is not the normal state which is in the system. So we reported, this is one of the case which we have, I'm referring here. So then we inform to the operator or the client here that this is not the normal state. It was not recorded. Yeah, it is not recorded in the system before, so you have to understand it. And then we highlighted this is the critical stage in your system, so which is a high resistance fault in a system. And based on that, we further evaluated this case and we have provided a necessary recommendation on this. So continuous monitoring, then transmission of a data, analyzing with the expert, and the diagnosis. So these are the parameters which need to be covered by the different, I will say, irrespective of industry type. It is helpful for the future systems. So with this, I will say Siemens is having this capability to evaluate this power quality data. So with the new technology, availability of the monitoring devices, so this is possible in the digitalization world. So let's put insight into action. Thank you.
Thank you, Segram. Power quality means different things to different people in the network. For somebody who doesn't have any electricity 24 hours, even 24 hours excess is a good quality power. Somebody who has 24 hours, but he needs at a constant voltage, constant frequency, no dips, his need is different. And as the economy is progressing, more and more such demands are going to be there, especially when there are a lot of power electronics which are coming into our network, both at the source side, that is the renewables, and at the consumption side. So as this pollution is happening in the waveforms, many new problems are going to come, like heating of our equipment, burning of our equipment, which needs proper detection and proper study for power quality. So that is going to be an area where a lot of new investment will be needed from the manufacturers and system study point of view. So next in this panel, I would like to invite Mr. Ashish Trivedi. Mr. Ashish Trivedi from ABB, sir.
Good afternoon. So, waiting for the lunch, I suppose. Anyway, we heard a lot about power distribution and power quality. What I would be talking to you is more closer to us as a consumer and how this can be addressed. So, coming closer to the consumer is where we are into the buildings. And what are the concerns, what we have as a user into the buildings, be it the operating cost, the energy cost, or the safety and security of the equipment and the people inside. So these are the issues which we time and again face when we are using the electricity out. What we can do with solutions designed to address these issues, we can reduce the cost of the installation by around 30%. The energy efficiency part, when we talk about CO2 emissions, which are a cause of concern, can also be controlled by effectively planning and utilizing these solutions. The safety, of course, more reliable the equipments, lesser are the chances of the incidents to happen, and safer is installation. And of course, that brings us to reliability, where unless we have a reliable solution, which is sort of fail-proof, we cannot assure continuous power and safe power to the consumers. So how do we do it? The conventional equipments, and when I'm talking about equipments, it's more closer to the customer, the LV switchgear and the medium voltage. And I'm putting unconventional methods to control these conventional equipments, which brings them to a solution which we provide, which we call ABB ability, and electrical distribution control systems, what you call it generally. What do we do into this? A conventional switchgear getting controlled, monitored, and effectively used through a network, cloud-based platform, where you can control it remotely, have all the analytics done. And this is effectively monitored through a software, what we call is a eKeep. And what can we get from that? The benefits is saving on the maintenance cost as well. One, which we address, is the installation cost. Second is the saving in the maintenance cost, which can be up to 50%. How? By way of predictive maintenance. What we normally do as a reactive, now when you move into a predictive, it can give you a saving up to 50% of the cost. The heart of it, the eKeep module. What does it do? Okay, any module to that effect, I would say. What does it do? It aggregates the data from all the equipments, the conventional equipments, sends the data through a cloud platform to the controller of the command center or a small PC at your home, or to your mobile or an app or a tab, and gives you the full control of the system. You are update every minute on what is happening to your system, what is the consumption pattern, where the issue is going to come. This is what the modules can do. Going further, you can embed this into any of your existing installations and make your installations intelligent. This gives you the real-time status of any equipment performing in your installation, thus making your installation scalable. Existing installation embedded with a module will give you a more scalability and more control on the system. Moving to the equipments, making the equipments more intelligent. Rather than putting a model, if you are going in for a new installation, you can always go in for the more advanced equipments, which has all the features embedded into them. An example is the breaker what we have. The controller can give you the complete power and data monitoring and control, and this can be clubbed to your cloud network and accessed from remote. This gives you a very good ease in using the equipments. Even on the MV switchgear part, we have equipments, or the equipments today have become so intelligent that you can control them remotely sitting at one place. Just to give an example, sitting in Mumbai, you can control an installation at Delhi as well. To an extent where you can see what is the position of the contact, analyze the life of the product, even after a fault, how much life is left, how much more it can go through, and thus plan your predictive maintenance activities so that the reliability of the system is maintained. You can get the power 24/7. And how do we do this? Of course, today we talk about IoT, but effectively utilizing it is one part of it. So digitalization into the equipments and the systems can bring about this change. And using various platforms, you can always have the control of your equipment sitting at one place. And how is it useful? Today we are having multiple assets. Any institution, any organization, they talk about having multiple assets at multiple locations. So the control and command from one place is all the more becoming essential. A system which can give you a total analysis right from the designing stage till the end of the life of the installation can help you in multiple ways, which is called building information modeling. Right from the designing stage, implementing effective measures, you can have the correct solutions designed, installed, and up and running so that for the whole life of the system, you get a reliable power, effective maintenance of the system, and thus reducing the cost, increasing the comfort. Talk about the final and controlling. Even when you give the power to the consumer, unless it is controlled and utilized properly, it's going to be waste. So how do you reduce the wastage of power or make it more efficient? By controlling it through the control systems, the lighting controls, what I call about. The KNX-based systems can give you various options by which you can control your lightings, thus making the system more efficient. And the most important, the platform which gives you a single window to have all your problems addressed. Normally it takes a lot of time to decide on what to do and what not to do to an installation to make it more effective. With Ability platform, what we promote, you can have all the information at on one table or on one screen, and that will give you a faster decision and implementation of solutions for a reliable system. This combined with a system which can give you a service support, which will be a remote care, wherein all your installations can be monitored by an external expert, sitting at one place and giving you the inputs on what next steps to be done. This is what we call as a complete solution and the modernization into the distribution network. Yeah. So you can always rely on the experts. I don't have to talk much about this. And adding a last point, when we talk about the technology, even today, the charging systems, the EV charging, which someone mentioned in the earlier sessions, can be made more faster and more efficient. A DC fast charging system which can charge your vehicle for 200 kilometers in 8 minutes. That's what is the solution what we can provide again. Thank you.
Ashish, so you would like to? Okay, I think he's gone to look for that photo. Is there presentation? Laptop? No, it didn't come on time. So probably Simar, you will start. We'll look for that and play that photograph.
Namaskar, good afternoon to everyone. It is very difficult to speak just before lunch because of two reasons. It is like a Bollywood movie because you have to, the villain is the lunch right now, the villain is me right now, and the lunch is the hero. So I have to either give a very strong presentation or either the hero will win. So my congratulations to, first of all, to the entire IEEMA team for organizing a stellar conference. Vikramji is here, he's been doing a fantastic job. Today, in the next 15 minutes, I'm going to speak very extempore to all of you out here. I'm going to discuss two things because I think all of the presentations have happened and I don't want to, further drag on a lot of things. I want to discuss and so that we can have an interaction session of about the modern power distribution equipments. So on the first part, I'll very briefly explain what we at Hartake are doing and how we are adding value to every consumer. The second part, I will explain about the true modern power sector situation right now and what is the way forward as of now. At Hartake, we started in 1991 and as an organization, it's been roughly almost 3 decades now. We're into 3 businesses per se. The first business is into power infrastructure. So we set up these high voltage and extra high voltage substations up to 400 kV and above across the country. I will touch base on that, as I move forward with the extempore because if you see the distribution system at large, infrastructure is the touch point, right? The companies who are actually building infrastructure is the touch point because all the technology is going to integrate ultimately. Jitni bhi technology ban rahi hai in this entire world is going to ultimately integrate from the infrastructure player. So we with the power infrastructure business are very, very clear in which to connect the end consumer with reliable power. Now, as Vikram pointed out, quality power and reliable power has a separate definition to everybody. Now, what does quality and reliable power means is integration of the top-notch smart equipments to the end infrastructure. So that's what we're doing at Hartake. We build more than 200 plus projects for our power infrastructure business. The second business that we are into is the renewable power infrastructure, in which we build these solar projects and rooftop projects across the country. We've done 1.5 gigawatt of solar to the grid. That's third largest in the country, and about 20 megawatt of rooftop in the country that we've done. A very interesting point which I would try to make of the power distribution. If you see the generation, transmission and distribution parameter, the rooftop is the only source of electricity which it is self-sustaining. If you see thermal, आप अपने घरों में कभी thermal नहीं लगा पाओगे. Or, you would never hear that, consumer is generating a hydro plant, a mini hydro plant at their home. It would be, so if you see a rooftop solar plant is ideally basically built to connect every consumer to the grid. So that is part of the modern distribution system. We are not talking about that. All we are talking is maybe about a transformer, we're talking about a package substation, we're talking about RMUs, we're talking about VCBs, but we are also not talking how, if 300 million people in India are still not connected to the grid, how will we connect every consumer to the grid? Nobody is discussing that. So what we're doing with rooftop projects is we're connecting every consumer to the grid, and that's the whole significance of it. Our third business is into manufacturing. So we manufacture these smart electrical switchboard panels, 11 kV and 33 kV panels to the end consumer. The whole idea of building these panels, we are building Punjab smart grid orders of Jalandhar, Amritsar and Ludhiana. The whole idea, if we talk about the distribution system, is connecting the end consumer to the reliable power. So these 11 kV and 33 kV panels are designed with modern relays so that they equip and connect the end distribution system. The fourth business is into smart cities and smart grids. इंडिया में ना आजकल एक जो स्मार्ट वर्ड और डिजिटल वर्ड है, आई जोकिंगली से दैट स्मार्ट और डिजिटल कोई भी वर्ड के पहले लगा दो पीपल सुनने लग जाते हैं. बट व्हाट इज अ स्मार्ट सिटी? A smart city, we can only talk about a smart city unless and until we do not have a smart grid. जब तक हमारे पास smart grid नहीं होगा, we cannot talk about a smart city. And what is a smart grid? A smart grid is mere all the grids of a distribution system talking to each other, interacting with each other with automation and relays. And what we're doing in Hartake is we are building smart grids across the country from the non-automation side of it. We are focusing very heavily on the northern part of the country, and through our expertise, through our power system expertise, and through our various expertise, we're building that and way forward. As I said that, I will not let the villain win, which is me and the lunch. I'm finished with my first part, which was explaining about what we are doing at Hartake. My second part is a very one-to-one interaction which I wanted to have with all of you out here. You know, all of the esteemed guests have spoken. They've spoken about the various products. I would, request that today, this forum, I would want to take this opportunity for the next 5 minutes and speak that Bharat, India has come a very long way from independence. 350 gigawatt is the power installed capacity. And there is so much emphasis that has gone on generation. We keep talking about generation, and mind you, just to give you a data, jitne bhi non-stress assets hain, 1 lakh crore non-stress assets come from generating companies. But nobody discusses about transmission and distribution. It is high time that we as the entire country have to come together at one platform and make India a much more sustainable country in the way forward. It is not one company that can come together. There are still 1 billion people in this world. 100 crore ऐसे लोग हैं पूरे दुनिया में जिनके पास अभी भी electricity नहीं है. That is almost equivalent to a country. So my message out here, which I want to wrap this up, is 2 things. One, we all need to work together in ensuring a modern India is made. Modern distribution बहुत बाद में आता है, पहले modern India बनता है. Modern India is made with a reliable and a smart system with every household with reliable power. That is one. And secondly, as I said, India is a great country, and people keep on saying that, it is a country of 1 billion problems, and I would like to comment on that. People say it is a country of 1 billion problems. I see India as a country of 1 billion opportunities. Thank you so much, everyone.
Thank you, Simar. You did an excellent job. So one fundamental thing is always there when we talk of automation, smart grid, digitalization, analytics. All these are very important, very, very important. But in my opinion, more important than that is to build a good grid. So once we have a good grid, then we should talk about intelligence, digitalization, all these things come on top. So we have some time for question and answers. So if there are any questions, our panelists will be very happy to take them. I see your hand. Can we have some lights, please? Can we have the lights in the hall? Yeah, so please tell me your name. What is your question? Not a comment, please. A question, and to whom it is addressed, so that we can have a quick answer.
Yeah, I'm Manoj Lonkar from NetMagic, working in data center. The question is for the OEMs, specifically ABB, Siemens, and Schneider. Being the data center is critical load, we allow 1 to 2 hours, that is the downtime in a year. The voltage dip, which is causing the undesired operation of the chillers, which is part of, that is heat ventilation and air conditioning system. So, is there any particular initiative by OEM to mitigate such kind of, that is the issue, which cannot reflect or which will not reflect on the MV or the LV side? Once again, I am repeating the question. The voltage dip, which is not at all related with the customer, that is the problem may be taking place in the grid. So, that is 110 kV or 220 kV, that is the tripping causes the voltage dip at our end, that is at the customer end. So, is there any initiative taken by the OEMs to mitigate such kind of issue which should not reflect on the customer side, which is causing the undesired operation of the equipments?
Okay, who would like to answer this? Sangram, you.
Hello. So first of all, the problem which you have mentioned, so that need to be understood, because the voltage dip which you are mentioning here, so whether this is a transient phenomena or it is remaining in a system for a long time, so one has to understand first. As for the voltage behavior is concerned, that's why I mentioned in my topic, because the power quality is the utmost important. And the power supply or the distribution licensee or the DSOs are already taking so many steps to improve on the power quality. But with respect to your concern, one has to understand it, and then the remedial actions or the mitigations is possible.
Any other question? It's too dark. I can't even see if anybody raises his hand. Please say your name. Yeah, Atul. Okay.
Yeah, good afternoon, everyone. This is Atul Dikshit this side. I work as a transformation consultant. My question is to Mr. Ashish. I think the products which you kind of talked about with built-in intelligence and remote monitoring and a lot of flexibility which will be offered to the operator, system operator. How do you, since we are talking of a critical infrastructure here, how do you take care of the security part of it? Because with flexibility, you also get a risk on security. So how do you address those parts?
Yeah, I understand you are talking about the security when it comes to accessing the data from
remote control or data security.
Yeah, so these are all softwares which are protected softwares. So once you have to have byte, and then you have password protections always put into it, so that the access is restricted and limited.
But these are all IP-based system, right? It is easy to hack any IP system.
Yeah, I understand.
So what are any specific measures which are been taken to address these areas?
Okay. See, hacking is always the issue which will remain and which will remain a concern. But yes, as of now, no specific measures which are there into this for the data.
Okay, any other question? Yeah. No. So if we have no more questions, we would just like to invite some of our eminent persons in the audience to hand over mementos to the panelists today. So can I call Dr. Rajamani first? Dr. Rajamani is a stalwart. He is a well-known expert in the power sector. Mr. Rajamani, welcome, sir. Mr. Sunil Joglekar, Mr. Snail Shah from Torrent, and Mr. Shrikande. Sir, can we have you to hand over the mementos? Mr. Sunil Joglekar. Sivar. Mr. Snail Shah. Sangram. Mr. Ashish and Mr. Sales, sir, please be here on the stage. And Mr. Shrikande, one for meet them also, please. Guests here to make this effort to come here and associate with IEEMA. Yeah, and thank you, sir. Thank you. Thank you. And as a token from IEEMA side, we would like to give you some mementos. Thank you.
We just can't get enough.
Now we'll break for the lunch. We sincerely thank our lunch host, SNC, for hosting the lunch today. We'll reassemble at 2:15.